Okay, hello Cloud Gurus, and welcome to this lab where we're going to launch a MiG. No, unfortunately, we don't get to fly a Russian fighter jet. I'm talking about a managed instance group. So to start off with, log into the console with your user account. Ideally, select the same project as the challenge lab. Now, if you've already deleted that project, you can go ahead and recreate it quickly, which would be good practice, or you could use the Services Exploration Labs project. In any case, I'll be using the Challenge Lab project, and I've cleared out the files from the storage bucket to make the new files from this lab easier to see. The other thing you'll need to do is to open up the Challenge Lab startup script, as we'll be using that same one for this lab. Well, alright, I'll see you in the console. Well, okay, here we are in the console with the Challenge Lab project selected, and I've already navigated to Compute Engine. But this time, instead of going to the VM Instances subsection, let's go to Instance Templates, and press on the Create Instance Template button. Now I hope that your first reaction to seeing this is, wow, that looks familiar, because this UI is exactly the same as the UI used to create an instance. Well, okay, that's not exactly true. There are some very minor differences between this UI and the other, and it's your homework to list them. I want you to compare these two to find the few differences and think about why it's a difference between creating an instance and an instance template. Now I am going to give you the first one and point out that this instance template does not require you to select a zone. Instance templates are global, and you can create instances from them in any zone that supports the configuration. Now I'm going to call this instance template Worker Instance Template and select F1 Micro as the machine type. Scrolling down, I want to set the scopes to write to storage. And I want to expand the advanced settings so I can set some labels. Maybe say setting function to learning and made by to template. Scrolling down a bit, here's where we need the startup script. So we can select and copy that and paste it in. And like before, we'll get the metadata key name from the script, which is lab logs bucket, and set it to the path for our bucket. That's all we need to set for now, so we can press Create. That doesn't take too long to finish, but when it does, we can press on the name to look at the details. And here we see all of the things that we entered. But where's the Edit button? How would we change this template? Well, the thing is, you can't. Instance templates are immutable. You don't ever change them directly, but you can copy them and make a new one if you need to. Now we'll get to this Create Instance group in a little bit, but for now, let's just press this Create VM button. And now on the right, we see the same form that we normally see when we create an instance. Now let's call this Worker Instance from Template 1, and notice that we can change any of the details, including the region, zone, machine type, and all sorts of things. I'm going to leave this machine as an F1 Micro in the US East 1B zone, which is in South Carolina, and just scroll down and hit Create. Now while that's creating, I'm also going to hit this Create Instance button, and then choose to create one based on a template from the panel on the left, and on the right selecting Worker Instance Template. Of course, this is now no different than it was coming from the Instance Template section, but I'm going to call this instance Worker Instance from Template 2. And despite this change making it ineligible for the free tier and therefore using up a little bit of my free trial credit, I'm going to set this instance to be an N1 Standard 2, a 2 CPU machine, but also in South Carolina US East 1B. I'll create that machine, and it'll take just a little bit of time to finish creating. Well, now we have two machines running, and if we take a look at the first one, and go to its Monitoring tab, we can see that it's already started to do a few things, because of the startup script that we have. But if we imagine for a minute that this machine is pulling work packages from a PubSub subscription and doing stuff with them, but there are so many packages of work to do that it doesn't have enough capacity, That might be the kind of situation where we need to bring online a second instance, like we've already done here. And this instance is a bit beefier, more CPUs and more memory. But maybe instead of monitoring each of these instances separately, we'd like to group them. So let's make ourselves an instance group. So if we go to the Instance Groups section and press on Create Instance Group, let's call this instance group My Unmanaged Instance Group, and scroll down and set it to be an unmanaged instance group. Now, something I'd like to point out is that an unmanaged instance group cannot be multi-zone. If you choose multi-zone, the Managed Unmanaged radio button goes away. So we have to switch back to single zone to be able to have an unmanaged instance group. Now here in the region and zone, let's choose South Carolina US East 1B, and leave the rest of the settings the same until we get to this VM Instances. Here, we can drop the list down and add the two instances that we created. When we've added both instances, let's press Create. So now if we go into the Unmanaged Instance Group, we can see the two instances, and the Monitoring tab will show us information aggregated across both of them. So now that the graph shows us that it's not doing a lot of work anymore, let's go back to the members and navigate into this 2CPU instance. Because there's less work to do, we can stop this instance. This will leave the instance around in case we want to turn it back on again later, but we won't get charged for it while it's stopped. So while that's stopping, we can go back to our instance group, and in a short bit, it's finished. There's still not all that much work to do, but we can leave that one micro instance running for when some work does come in. But this is really not a happy way to be managing instances. This is far too manual of a process. I don't want to be starting and stopping instances all the time. So let's do it properly instead. Let's go back to the list of instance groups, say Create Instance Group, and this time let's call it My Managed Instance Group and make it a multi-zone group in US Central 1. Now we can choose to allow or disallow certain zones, but US Central 1 has 4 zones, so we may as well allow them all. But now when we scroll down, we see some things that are very different than the unmanaged instance group. In the unmanaged instance group, we were asked if we wanted to add some existing instances, but here instead we have to choose an instance template. Of course, we'll choose the worker instance template that we've set up, but I hope you're already thinking to yourself how this is very different. The key thing here is that Google will be creating and deleting instances on our behalf. It'll use this instance template as it is and automatically scale up and down based on what we set here. Now you can actually turn auto scaling off and then tell it manually how many instances you want, but that's really not ideal, so we're going to leave auto scaling on and tell it to auto scale based on the CPU usage. This says that when there's a lot of work to do and the CPU usage goes up, we want to add more instances. And when the work is finished and the CPU usage goes back down, we want to delete some of those instances so that we save money. Now I think it'd be a good idea for you to read some of the supporting documentation on this, but for the sake of this lab, we're going to leave it as CPU usage, but set this target CPU usage to a rather low 30, just so that we see the scaling happen based on the stressing that happens in the startup script. Now we want this managed instance group to always have at least one instance running, but let's set the maximum to 5 for this lab. Now this cooldown period we'll set to 30 seconds, and what this is about telling Google to exclude any newly created instances from the metrics that it's using to measure CPU and target. In normal circumstances, you want this cooldown period to be longer than the total amount of time it takes to start up the instance and finish running its startup script. But because we're using the startup script to simulate the work that's happening, we want Google to be considering all of that CPU usage and trigger a scale up. Since the startup script stresses the CPU for a couple of minutes, 30 seconds should do nicely here. Now at the bottom here, we see auto healing. This is another valuable thing. Now, as we've talked about before, if one of your instances for some reason dies, just crashes and shuts off, you want that instance to come back to life. You want Google to restart it. And that will also happen in autoscaling groups. Even if we don't do anything with this health check, an instance that shuts down will get restarted. But this goes beyond just that. This is about making sure that the instances are healthy to do the work that they need to do. If you imagine that you're running a program to pick up work packages, but something went wrong with it and it crashed, that won't necessarily shut down the machine. But if you have a health check that is continually asking that machine, hey, are you all right? How about now? Are you still all right? What about now? Everything good? Then if it doesn't get a positive response, it can say, all right, there's something wrong with you. You need to be refreshed. It'll delete the problematic machine and create a new one. No big deal. The instance template has all the information it needs, right? Now, the instances that we're dealing with aren't configured to respond to a health check, so we're going to leave this as no health check for now and hit Create. Now, while this is creating, let's open up a new tab and go to Google Cloud Storage. Here we can go into the bucket, and we see that the two instances that we created manually have successfully logged their files. If we open up an additional window and go to Compute Engine, we'll see that there's now a new instance that's been created as a part of the Managed Instance group. We can click on that and take a look at it like any other instance, even meddling with it, though that's a very bad idea. But in the Monitoring tab, we'll eventually see the CPU spike up. But more interesting than watching the individual instance is going over to the Managed Instance group and taking a look at what's going on there. Here we see that it is now scaling, and it says the number of instances is going up from 1 to 3, and now from 1 to 5, and now it says that it's created 2 instances, and that is targeting 5. 3 instances are now online, and if we go into the instance group, we'll see all sorts of instances. The Monitoring tab will give us some more information about what's going on when it has a chance to update. But if we look at the list of members, we can see that the instances are being spread out across multiple zones. This is very good from a robustness standpoint. If there were some unlikely event that affected a lot of instances, like maybe one of the data centers burning down or something, like I said, it's very unlikely. But if something like that were to happen, then losing a whole zone really wouldn't be that big of a deal. If we have our instances evenly spread out across 4 different zones, then even losing an entire zone should never cripple us. Now it's going to take a bit of time for this auto-scaling dance to play out, so I'm going to speed up the video for you. Okay, here we see that the auto-scaling has kicked in, so early on in this graph, when we had one instance, because that instance was significantly over the 30% threshold that we had set, Google decided it needed to add more instances. Lots more instances. And of course, because all of those instances are set to peg the CPU when they start up, the total usage just kept climbing, until eventually it hit the limit. 5 instances and no more. That's what we said. And that's why in the Members tab, it also told us that it hit the maximum. But back to this Monitoring tab, when the instance's startup scripts finished, the CPU was no longer pegged. And so the total usage was dropping significantly, but the capacity, which is 30% times however many instances are running at that time, stayed rather higher. So I'm going to fast forward a bit more, but because the blue line is now below the green line, Google should start deleting instances in a bit. Magic speedup time again. Hey, there we go, all the way back down to 1 instance, our minimum of course. Now unfortunately, because the 30% threshold is so low, it actually registered a need to add a second instance back, and that's going to start the whole cycle over again. because of course it's the startup script itself that pegs the CPU. But we've really seen what we needed to see in action now, so let's go and delete the instance group. It's already back up to 5 instances, but we just don't need them. And actually, while we're at it, we can delete the unmanaged instance group too. Now I hit the delete button on the managed instance group twice, so it shows a bit of an error, but it should work itself out shortly. If we refresh the bucket, we see that lots more files have been logged from the new instances that came online in the managed instance group. And if we go back to the list of instances in Compute Engine, we see the managed instance group instances in the process of shutting down. Now if we copy the name of one of these resources before it goes away, and link over to Stackdriver logging from the worker instance that is notably still around, then we should be able to change it to show all instances, but filter by that particular instance's name, so we can see the results of what happened to it. And here we see things like no shutdown scripts found in metadata. The value of pushing these logs to Stackdriver logging is that we don't still need to have the instance around to be able to tell what happened to it. A little further up, we see the information about the startup script. Now if we switch back to the instance groups, we see that they're all gone, but there's still the matter of a couple of instances that are left. And that's because deleting a managed instance group will delete all of its instances because it owns them. But deleting an unmanaged instance group will just leave all of the instances behind. So don't forget to delete these two as well. Some more time bending, and we're all done. Now I've just been letting these notifications pile up, but you can see all of the different things that happened. And I highly recommend that you look through both the notifications and the activities that you see in the log. This activity log is quite important, so you should make a habit of coming back here after you do things to see what shows up and what doesn't. Well, alright, to wrap things up, here are some key takeaways from this lab. I hope this has shown you that using instance templates is much better than manually creating instances. And this goes the same for the command line interface too. You can create both instance templates and instances from templates via the command line as well. Another thing I hope you take away from this is that managed instance groups are much better than unmanaged ones. Unmanaged instance groups have a lot more restrictions and are not nearly as useful. One of the reasons why managed instance groups are better is because they have auto-scaling, and auto-scaling is much better than manually managing the instances. If you set things up correctly, autoscaling will just do the job while you sleep even, taking care of all the ups and downs of load on your system. Another thing we've seen here is that we should treat most of the resources as ephemeral or expendable. Expect them to go away and design your system to handle that without trouble. This allows you to automate things because automation both requires and gives consistency. Because automation does the same thing each time, it has to be working against some known standard, and then it will give you a new predictable result. And this leads to my final takeaway, which is that everything depends on reliable automation. This is really a key theme of everything we do. Well, okay, if you have any questions, please let me know. If not, please feel free to move on to the next lecture. Thank you.